All right, ladies and gentlemen, I hope that you're having a great Wednesday. So today, really, all I want you to be able to do is to try the AP packet, excuse me, and try to get 4 out of 6 of those right. If you have time to watch this and try the challenge problem, excellent. If you don't, no big deal. You can try it another time, or you can just focus on the AP problems. You'll notice that I posted both my solutions and Galt's solutions. Check them both. We did some of the problems a little bit differently. All of our solutions are valid. I just want you to see some different methods that people could solve them. So please feel free to take a look at both of them. She tends to do them a little bit more like AP does them, with not a lot of justification, and that's perfectly fine. So however you guys choose to do it, I want you to be able to see multiple representations of how that works. So yesterday I gave you the problem of this bell curve, and I told you that this bell curve is always going to have a center right at mu, and I wanted you to prove that the inflection points are out here at mu plus sigma and mu minus sigma. So also that there was a horizontal tangent right at the average, and it changes from increasing to decreasing there. So on this page, I'm going to show that we have that horizontal tangent, and then on another page, I'll show that the inflection points actually happen at mu plus sigma and mu minus sigma. This is a tough problem, so hopefully I'll be able to get it right again, and we'll see what happens. So we're given f of x. We want to find f prime of x to be able to find the increasing, decreasing. So this whole guy out front here, that is a constant. So I'm going to forget about that for a second because sigma is defined, pi is defined, and we'll just think about what they are for a sec, and then we will go on from there. So this e to a power. The thing about take the derivative of e to a power, we leave it alone, and then we multiply by the derivative of the power. So 1 over sigma root 2 pi. I'm going to leave that alone. So we leave the function alone, e to the negative x minus mu squared, divided by 2 sigma squared. Then we multiply by the derivative of the inside function. Well, that 2 is going to come down, so we have a negative 2 times x minus mu, reduce the power by 1, which is just going to be the first power now, and then that's still over 2 sigma squared. And then multiply by the derivative of the baby, but the derivative of x minus mu is just 1, so I don't even have to do anything. The 2's cancel, and I end up with f prime of x equal to, going to bring the sigma squared out to the front here, so I have, and the x minus mu as well, why not? So we have negative x minus mu, so I'm going to write that as mu minus x, because it's negative x minus mu, divided by sigma cubed root 2 pi, e to the negative x minus mu squared, divided by 2 sigma squared. This is a little bit of a hint for one of your AP problems. E to a power, always positive, right? It looks like that. So it will never be negative. So this guy is always positive. So the only thing that's going to determine the sign of this is the mu minus x. So that's equal to 0 only when x is equal to mu. So x equal to mu is the only time we have a horizontal tangent, and we can make our sign analysis. So here's mu. Prior to mu, so if x is less than mu, this is going to be a positive value, because if x is less than mu, we're going to have a positive there. Everything's going to be positive. And then after mu, if x is bigger than mu, it's going to be negative. So we've just shown by the first derivative test, because f prime of x changes positive to negative at mu, mu is a max. Mu is a maximum. Okay, and that's all we have to be able to show for a first derivative test. Now, let's find the second derivative. So we're going to take the second derivative of this whole mess right here. Let's see if I can remember what it is and write it down. So we've got f prime of x is equal to mu minus x divided by sigma cubed square root 2 pi e to the negative x minus mu squared divided by sigma squared. So what we've got now is we have a product of two functions. You could split it up differently, right? You could break this apart because it's a heart, so you could do mu over sigma squared root 2 pi, and that'd be a constant. Then we'd have minus x over sigma squared root 2 pi multiplied by this, but I mean, we might as well just leave it alone because the derivative of this is not hard, right? The derivative of this is negative 1 over that denominator. So we're going to use product rule. So f double prime of x is going to be, let's leave the, let's do the derivative of the first one first. So negative 1 over sigma cubed root 2 pi, right? Because the bottom's just a constant, so we just deal with the negative one on the top. Leave the second function alone. E to the negative x minus mu squared over sigma squared. Is that supposed to be 2 sigma squared? Yes. Sorry, my bad. Okay, and then plus, leave the first function alone, mu minus x, divided by sigma cubed root 2 pi, multiplied by, well, the derivative of this we already took. We did it in the last slide, right? This is the derivative of just the e part, right? Because that was what we figured out the derivative to be. We don't have the 1 over sigma root 2 pi, so it's a little bit simpler, but all we're going to have is we're going to leave it alone. E to the negative x minus mu squared divided by 2 sigma squared, multiplied by the derivative of the baby, which is just negative 2 times x minus mu, all divided by 2 sigma squared. Derivative of the baby is 1, so we don't have to worry about it. Now we can factor some stuff to the front, and let's see what we got here. So, if we pull out, let's see, e to that big messy power, will that help us? Well, let's do an extra step here. I don't want to get ahead of myself. So f double prime of x, let's leave this alone. So we have negative 1 over sigma cubed root 2 pi times e to the negative x minus mu squared divided by 2 sigma squared. And then let's mix all this together. So the 2's cancel. We have a negative, so this is mu minus x times mu minus x. So we have mu minus x squared divided by sigma to the 5th root 2 pi. And that is times e to the negative x minus mu squared. Sorry, squared on the outside. All divided by 2 sigma squared. Now to get a common denominator here, to make those the same, well, I'm getting ahead of myself again. So we're going to factor out an e to the negative x minus mu squared. So f double prime of x. Factor this out because it's shared in common. So we have e to the negative x minus mu squared, inside again, come on, divided by 2 sigma squared. That's multiplied by a negative, I'm going to do this in one step. So to get a common denominator here, I just need this sigma to be up to the 5th. So I'm going to multiply this by sigma squared on top and sigma squared on the bottom. That'll give me sigma to the 5th root 2 pi on the bottom. So I have a negative sigma squared plus, now I'm actually going to FOIL this out. So we have mu squared minus 2 mu x plus x squared, all divided by sigma to the 5th root 2 pi. Now, we're interested in showing the inflection points. So we want this to be equal to 0. We want to show that there's a sign change at this point. So, this guy, once again, is always positive. So this fraction here is the only thing that's going to determine the sign of this derivative. So I just need the top of this fraction to be 0. Well, doesn't sound so hard, right? Except we have all these symbols in there. So we need x squared minus 2 mu x plus, let's put this in parentheses because it's a constant, mu squared minus sigma squared. Need that to be equal to 0. Now, this is a quadratic in x. The a value is 1, the b value is negative 2 mu, the c value is mu squared minus sigma squared. So one option we have here would be to put this into the quadratic formula. Yuck. A is 1, b is negative 2 mu, and c is mu squared minus sigma squared. Now, there are some better ways to do this. One is you could complete the square, also kind of yuck. And remember, the other way to solve for zeros here is to factor. So let's see if we can maybe be clever about this and factor it. And I wouldn't expect you to have to be able to do this ever. But this guy right here is a difference of squares. It's a difference of squares. And part of the reason I realized that you could factor this is because I know what we're going for, right? We're trying to show that this happens at mu minus sigma and mu plus sigma. Those are not ridiculous values. So we can probably somehow factor this. This guy at the end here factors into, it's a difference of squares, mu plus sigma and mu minus sigma. Well, that's handy because that's pretty close to what I'm trying to find. So we have x squared minus 2 mu x plus this guy right here is equal to 0. Looks like I need another slide. Let's bring this down, keep them, and let's make another slide here. New slide. There we go. Okay, And we're going to take that formula right here. Let's see if I can highlight it and copy it. I don't know if they'll let me do that. Probably not. Copy the whole thing. That won't help me. All right, so we'll just kind of come from one to the other. So we have our second derivative here. Well, we're trying to find out if this is equal to 0. So x squared, I'll change colors, that's okay, minus 2 mu x plus mu plus sigma times mu minus sigma. We're trying to show that that is equal to 0. Trying to find the values where that's equal to 0. And what we have here, if you remember, like if you're trying to factor, let's see if I can make up a factorable equation, x squared, let's do x squared minus x plus minus 6, something like that, equals 0. So remember, to factor this, you have to think, okay, what are the factors of 6? Well, 2 and 3 work because I can get a 1 out of that. Factors of 6 are 2 and 3, and then we need a minus 3 and a plus 2. So then we have our factors. It works the same way here. I need two things that multiply together to give this constant. Well, I've got them right there. Okay, and then we're just going to have to show that it works out to be the negative 2 mu x. So if we do mu plus sigma and mu minus sigma, and those are our roots, then we have to have x minus those two values. And we also see, since we have a negative here and a positive at the end, it must be a negative times a negative to get that positive. Now we can check this by foiling if we want to. X times x is x squared. X times negative mu minus sigma would give me a negative mu x and a positive mu sigma. Here we get another negative mu x and a negative mu sigma, so that x sigmas would cancel. We'd have a positive x sigma and a negative x sigma, which would cancel. We have the negative 2 mu x. And then multiply the last two, the two negatives cancel, and we have our final term. So this tells me that the two values that give me 0 are mu plus sigma and mu minus sigma. So those are my two x values that give me 0. Now we're almost home free because we've shown that there's 0. The second derivative is 0 there, but that's not enough to guarantee that it's an inflection point. We would have to show on a number line that mu minus sigma and mu plus sigma, that there's actually a change there. Well, that's really easy to do with our factored form here. These are both single roots. If you remember your multiplicity of roots from last year in pre-calc, if it was a double root, it could bounce. If it was a triple root, it would still pass through. But since they're both single roots, it means there has to be a change there. This is a quadratic. It means that we have to either go from positive to negative or negative to positive at mu minus sigma and mu plus sigma. All right, and since we have a positive x value, we know our end behavior is going to look like this. So this is a parabola that looks like this. So it changes positive, negative, positive. So we've shown that our inflection points are at mu minus sigma and mu plus sigma. So if you were looking for some fun algebra to do today, I hope that you found it here. Only took us about 13 minutes to do. So hopefully you were able to get this challenge problem. I hope it was as much fun for you as it was for me. I've always wanted to do this problem, and it was pretty cool that I was able to share it with you guys. Now, it is Wednesday, and as much as I want you to do those AP problems, maybe you'll whip through them and you'll have some time to give this a shot. What I'd like you to do is pause this and try this by yourself. What happens here is each letter represents another letter in the English language, and it stays the same all the way through. So we see we have a question. That's one good hint that maybe we have some kind of a question word here somewhere. And then single letter words, well, you only got two options there. It's A or I. And then other hints you can look at. I would maybe start with words like this guy right here, starts and ends with the same letter, and we see that starting in a few other spots, that JA. So there are common things that happen in the English language that help you solve these Cryptoquips. So give it a shot, pause the video. I'm going to wait a few seconds here so you can pause and try it, and then I'll show you how to do it. All right, hope you figured out my little joke here. And what I'm going to do now is I'm actually going to try solving this, and we'll see if you get the same thing I did. So I kind of gave you a hint that I would maybe start at this word because these words we see start with the same two letters. Real common word in the English language that starts and ends with the same letter is that. All right, four-letter word starts and ends with the same letter, and it also gives us a real nice intro to the word the here, because the comes up all the time in English, and th is a real common starting with two letters there. So we have a th here as well. Now I'm going to fill in all the rest of them. So J is a T, so everywhere I see a J, I'm going to put a T. I think that's all of them. Got an apostrophe here, that's another good hint. A is H. So there's an H. There's an H. Where else? Here. And I think that's it. Okay. So then B is A. B is A. Uh-huh. Any more? One right there. And then we have an E. E is the most common letter in the English language. Whenever you have no idea what to do starting one of these, count all the letters, each one. So you'd be like, A, how many A's are there? How many B's? How many C's? On D on this one, we found out we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 D's. All right, you can do the rest of the analysis on this. I'd be very surprised if there were 8 of any other letter. Yeah, I don't think there's 8 of any other letter. So let's plug in all of our E's here. We already knew it was E, but if you're just at a loss, you can kind of say, well, maybe the one that occurs most often is E, because E is the most common letter in the English language. Ooh, getting some good hints there. Okay, so we've got our D's there, or all of our E's, and now what we're looking for is somewhere to go next. Well, there's only a couple options here. And where I'm actually going to go is right here. So THE something apostrophe blank E. Well, it could be there, THEY apostrophe RE, or it could be they've, the THEY apostrophe VE. H is in common here. If it was a V, I would have HEAV here. Doesn't look good. If it's an R, though, I have here. Here, that, there. Oh, interesting. So H is going to be R. Some other ones here. H is R. And then we have E is Y. Ooh, starting to get a good idea of how this is going to start here. It's a question. So we'll see what happens there. So E is Y. I think we got them all. So this, now just looking at this, this is probably have something, and then this HEARS maybe, it could be hears, but I think this is have you heard. Have you heard? So that's kind of a common way to start a question. So let's see here. Is there any other C's for a V? There we go. And then we have F is O. And G is U. I think that's the only one. And then I is D, we just filled in. Any others of those? Doesn't look like that. So have you heard the something, something, something? Well, we've used A, so this O's got to be an I. Okay, O is I. O is I think that's all of them. Well, let's see here. This one starts and ends with the same letter. We might be able to do something there. We've only got one letter here left, and whenever you have a one letter left in a word, if you can't think of a word that it could be, you can run through the whole alphabet. A, B, C, D, E, F, G, H, I, J, K, L. L, viral. I think that's the only word I can put there. V-I-R-A, I don't think there's any other letter that would fit there. So, that means K is L. Later, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, S. Latest. Have you heard the latest? L is S. Any other L's? I don't think so. Have you heard the latest? What could this be? Well, viral. Viral. So often these are kind of jokes. So if we have a viral here, this could be Ebola, like a virus. Interesting. Have you heard the latest Ebola something? I hear that there. Well, let's focus on this word that starts and ends with the same letter. So A we already used. B, B-O-I something. B, I don't think so. C, I don't think so. D, D I think we've used. E we've used. F, F-O-I-F something. F, I don't think so. G. Oh, how about G? G-O-I something G. How about G-O-I-N-G? Oh, going viral. Have you heard the latest Ebola something? I hear they're going viral. What goes viral? Well, videos go viral. How about a joke? Have you heard the latest Ebola jokes? I hear that they're going viral. And now you can giggle at my little pun or groan or whatever you want to do, but hopefully you learned a little bit about how to solve these puzzles today. They post one of these in the Star Tribune every day. So if you get the Star Tribune at home, They put these right above the comics, right by the wuzzles, and I do these every morning before I come to school. It's just kind of a way to warm up my brain and get me going as I'm eating my cereal, and they're kind of fun. They always give you a hint. They give you like a single letter hint, like in this one, because we had that trouble getting that last word, they might tell you maybe like N equals K, or maybe they give you something else. They might give you like K equals L or something. Okay, so they might tell you that letter, but they always give you a hint. I try to do it without the hint, and then if I need it towards the end, I give it a shot. So hopefully this was fun for you, and hopefully you were able to get some of the AP problems. I love you guys. That's why I'm here. Have an excellent day, and I will see you tomorrow. See you tomorrow. We'll do some review, do 4.4, and the quiz on 4.1 to 4.3 will be on Friday. Talk to you guys soon. Bye-bye.